Okay, if you look at the first column, it's indicated as the swimmer's weight. And 60 kg is the mass and not the weight. So you can eliminate option A and B. So now we know that the swimmer's weight is 600 Newton. So if the weight is equal to 600 Newton, the mass is equal to the weight divided by gravitational field strength, which is given as 10. So the mass is 600 divided by 10, 60 kg. So the resultant force is equal to MA. Okay, so it's equal to 60 multiplied by the deceleration. Okay, in this case, right, we can just use the deceleration as the acceleration because we are just concerned with the magnitude and not the direction. So it will be 60 multiplied by 16. So this will give us 960 Newton. So the answer should be option C. Okay, question 7, right, is a recall question. We have to understand that the inertia is actually a resistance of the body to change its current state of motion. So the answer should be C. Okay, in this question, we have a golf ball and a tennis ball falling in a tube of air and vacuum. Okay, so we are asked which ball will take the shortest time to reach the bottom of the tube. The balls in the air tube is out of the question because the air will provide air resistance to oppose the falling of the two balls. Okay, so now we look at the vacuum tube and we have two different balls. Okay, actually anything that is falling in vacuum, it will fall with the same acceleration due to the gravitational field. So whether it is a golf ball or tennis ball, they will fall with the same acceleration, hence the same speed. So now the difference is on Moon and on Earth. On the Earth, right, the gravitational field strength or the acceleration due to gravity is about 10 meter per second square. And on Moon, right, the acceleration due to gravity is around 1.67 meter per second square. So obviously, the tennis ball will fall faster because of a higher acceleration. So the answer is D. Okay, we have an object that has a mass of 2 kg and a weight of 20 Newton on Earth. So when the object is being taken to the Moon, the mass will remain the same because mass is the amount of substance in a body. So it should remain the same no matter which planet it is on. Whereas for the weight is equal to the mass times the gravitational field strength. And the gravitational field strength on Earth is larger than the gravitational field strength on the Moon. So the weight on the Moon will take the mass multiplied by gravitational field strength of the Moon. Since the gravitational field strength of the Moon is lesser, the weight will be lesser. So the answer is C. Okay, for this question, we are asked to calculate the density of the stone. Density is equal to mass over volume. So the mass of the stone is 120 grams. And the volume of the stone will be the difference in the water level, 90 minus 30, that will give us 60. So 120 divided by 60, we have 2 grams per cubic centimeter. Answer C.